So we continue with the static electricity. It's the second part of it. Now, so we are discussing over here the conservation of charge. So before rubbing the two objects, each object is uncharged, so the net charge is 0. Okay. If I take two objects and they are not charged right now, so then the net charge on both of them is 0. Now when two objects are rubbed together, both are charged equally, but the charge on one of them will be opposite kind. Thus the total charge of the object before and after rubbing remains the same. This is called as conservation of charge. What do you mean by this? If I take glass and silk and I rub them together, if a small quantity of charge is being generated or being formed on the glass rod on a positive charge, it will be seen that exactly equal amount of negative charge will be formed on the silk. So the total charge of this over here positive and over this negative will again be 0. That means that the total charge of the combined thing will always remain constant. Okay, so the total charge of the object before and after the rubbing is always going to remain the same. This is called as conservation of charge. For example, when a glass rod is rubbed with silk, the glass rod is charged positively and the silk is charged negatively at the same amount. Similarly, when an ebonite rod is rubbed with fur, the ebonite rod is charged negatively and the fur is charged positively by the same amount. Let's take a small example over here so that we can understand it more clearly. Suppose I take a particular glass rod. Now suppose this glass rod over here. See, basically what is the charge? Charge is nothing but the electrons. So the electrons which are there, they are going to move from one place to another place. And that particular movement is available to them because of the friction. See, electrons will not be able to jump one body to another body. Okay, they were not able to jump from one substance to another substance, but when they are coming in close contact and we are rubbing it, we are producing friction, we are producing heat energy, that is kinetic energy being produced, which gives the electrons the capacity to jump to the next material. So if I take this particular glass rod and we have got the cloth, which is the silk cloth over here, suppose it is this way that this glass cloth has got, let's say, 100 protons and 100 electrons. Okay, the silk cloth over here has got 50 protons and 50 electrons. See, they are neutral. We know that the number of protons, the number of electrons present in any particular atom is going to remain the same. That's why you have got over here that 100 protons and 100 electrons. This is just a small example. There is nothing like something which you can write as an answer, but just to make you understand, I am giving you this example. Now when I rub them together, what will happen is that, let's say 25 of these are going to move and enter over here. So now what happens, on rubbing, here the number of protons remain 100, but the electrons have become 75 now. And over here the protons are still 50, but the electrons have also become 75 now. So it is seen over here that this over here, electrons are being more, hence it causes a negative charge, and over here the electrons are less, so hence the protons are more, hence it gives you a positive charge. But if you see the total amount of electrons present before and after is what? Before it was 100 plus 50, so it is 150 electrons, and after also it is electrons are 75 plus 75 is equals to 150 electrons. So the number of electrons before and after this particular process of charging is going to remain the same. This is called as conservation of charge. The charge which is going to be produced is going to be conserved. So इधर यहाँ पे जितना add हुआ उतना यहाँ पे subtract होगा, और जितना यहाँ पे subtract हुआ उतना यहाँ पे add होगा. So explanation of the rubbing of the charge. Each body has atoms. An atom is electrically neutral. It has protons, positive charge, and neutrons, uncharged, inside its nucleus at the center, around which the electrons, negatively charged, revolve in different orbits. So we have learned it in the chemistry, the atomic structure. So nucleus is the center with protons and neutrons at the center, and the electrons are revolving around them. The orbits. The number of electrons in an atom is equal to the number of protons. However, some of these electrons can easily leave their atoms. These are called free electrons. So जो valence electrons है in which can move around, so these are the free electrons. They are called as free electrons. So these free electrons can move around inside that particular body. The two objects when rubbed together are initially neutral or uncharged. When they are rubbed together, the free electrons are transferred from one object to another object. So when these two are rubbed together, the free electrons of the glass are moving and entering on the silk. So the free electrons are transferred from one object to another. The object which gains free electrons becomes negatively charged, while the object which loses free electrons becomes positively charged. So this is how the charge is being formed. The one which is going to lose electrons over here, glass loses electrons, becomes positively charged. The silk gains electrons and then becomes negatively charged. For example, when a glass rod is rubbed with silk, the free electrons from the glass rod are transferred to the silk. The glass rod loses some electrons, so it becomes positively charged, and the silk gains some same number of electrons, so it becomes negatively charged by the equal amount. The charging of glass rod and silk on rubbing is shown in the figure. So they are given here. Before rubbing, both the glass rod and silk are electrically neutral. While rubbing the glass rod and silk, electrons are transferred from glass rod to silk, and hence after rubbing, the glass rod becomes positively charged and the silk becomes negatively charged. When an ebonite rod is rubbed with fur, the free electrons from the fur are transferred to the ebonite rod. The fur loses some electrons and it becomes positively charged, and the ebonite gains electrons and becomes with the same number of electrons and become negatively charged by the same amount. The charge of the ebonite and the fur on rubbing is shown in figure 8.25. So you can see in figure 8.25, before rubbing, both the ebonite rod and the fur are neutral. While rubbing the ebonite rod and the fur, electrons are transferred from the fur to the ebonite rod, and finally after rubbing, the ebonite rod becomes negatively charged and the fur becomes positively charged. So this is how the charging of the thing takes place, and also it is seen that the charging takes place in such a way that the total charge of a combination remains the same. So that is nothing but conservation of charge. Now, when we are talking about the charging, it will be seen that there are two kinds of substances in nature. One is the conductor and other is the insulator. We know very well that conductors are those which allows electric current to flow through them. So when the electric current can easily flow through them, they are called as conductors, and when the electricity is not able to flow through them, they are called as insulators, or bad conductors or non-conductors. So let's see. In class 7, you have learned that substances such as silver, copper, aluminum, iron, brass, steel, mercury, carbon, human body, etc. are conductors of electricity. Okay, that means they allow electricity to pass through them. All metals, most of the metals like aluminum, gold, silver, all these, even human body are all the substances which allows electric current to pass through them, and hence they are called as conductors. They allow electricity to flow through them, but substances such as cotton, rubber, plastic, wood, paper, etc. are insulators of electricity. They do not allow electricity to flow through them. So all these which do not allow the electricity to flow through them are called as insulators. So let's see what is the reason behind any particular substance being a conductor or an insulator. So the reason for some substances to be conductors and others to be insulators of electricity is that different substances have different number of free electrons in them. Substances which have a large number of free electrons are called as conductors. So either there is they have got free electrons, but some have got very few amount of free electrons, another have got a large number of free electrons. So if the number of free electrons is very large, then the substance is a good conductor. If if the number of free electrons is less, then the substance is insulator. So substances with a large number of free electrons are called as conductors, while those with very less number of free electrons or no free electrons are called insulators. The conductors allow the charge to flow through the motion of free electrons, but the insulators do not allow the charge to flow because free electrons are not available for motion. So whenever there is no availability of the free electrons, then that particular electrons will not be able to move around, so they will not be allowing the flow of electrons to them, hence that is insulators. And it can be seen that only the insulators, it's only the insulators which can be charged with friction, because अगर मैंने कोई conductor को लिया और rub किया, what will happen? It has got free electrons. So the moment it is getting charged, the charge is going to pass through, because it is free to move around, right? They have got more and more free electrons, so it is free to move around, and that's why the charge will just pass through. So it will be just, the charge will not be formed. The formation कब होगा? जब वो वहाँ पे retain हो. Static electricity is when there is the electricity such that the charge is at rest. But in case of a good conductor, the charge will not be at rest, it will be moving. And because it is moving, that's why it will be not be forming into static electricity. So that's why the conductors cannot be used for any of these particular kind of static electricity experiments. But if it is a bad conductor or insulator, only then you can use them for static electricity. So only insulators can be charged by rubbing or by friction. The conductors cannot be charged by rubbing because charge developed on them will flow away and will not remain with them. Okay, so that's it. So charge होगा वो, but क्या होगा? The charge is going to flow through them. It is not going to remain there. What you want is that the charge should remain there for you to do the experiment. But यहाँ पे क्या होगा? If you rub it, like if you take a copper rod and you rub it, तो copper rod में से electrons जाते जाएंगे, and possibly you are also a good conductor, it will pass through you and go into the earth. So no use at all. It is not going to charge at all, right? So the conductors cannot be charged by rubbing because charge developed on them will flow away and will not remain with them. So that's the reason that whatever experiments we are doing, the experiments will always have the use of insulators like glass, silk, ebonite, fur. All these are insulators. So because they are insulators, they can be used for the process of static electricity. Now let's see that if I am going to charge a body, so first option is, of course, I can charge the body with the help of rubbing. Okay, I can rub, get the charge present over here. But what if I don't want to rub and I want to get the body conductor to be charged? So these are certain options, okay, the methods of charging the conductor. Methods of charging a conductor. You have learned that two insulators can be charged by rubbing them together, but a conductor cannot be charged by rubbing it with another conductor. A conductor can be charged by the following two methods. So now if I want to charge a conductor, okay, so now what we are trying to do is that we are going to try to make a good conductor have static electricity in it. Now that is possible only when that particular conductor is not connected to the ground by any good conductor. That means suppose I will take an example of, suppose this is made up of metal, okay. If I am holding it, it is getting connected through me to the ground, so this cannot be charged. But if I suspend it by a thread or I suspend it by an insulated stand over here like this, in that case, whatever charge is present can be within this particular limits. Okay, let's understand this thing in proper manner. So, a conductor can be charged by the following two methods, by conduction and by induction. So, first of all is by conduction. Right? So what we do over here is that we are going to take a good conductor. So this is a good conductor. So maybe we can take copper, aluminium, steel, anything. Okay, we can take a metal rod, basically a metal rod. But this you are fixing on a insulated kind of a stand. Okay, so this is a insulator. That means even if there is a charge present over here, it has nowhere to go except this particular conductor. It cannot travel down because it's insulator. It will not allow the flow of electrons. The electrons can move only within this particular area. Okay, we are seeing to it that that particular metal rod is placed in such a way that it is not coming in contact with any person or any good conductor, so that it can allow the flow of electrons from itself to somebody else. Insulating material will not allow the flow of electrons, so automatically it is not allowing it over here. So what happens? Whatever charge is present on the good conductor will remain inside the good conductor only. Right? So we are going to charge this particular good conductor with a particular method which is called as conduction. Conduction means you are going to touch this particular good conductor with a non-conductor which is already charged. Okay, so what you do is, suppose this is the glass rod, silk liya, rub kiya. So what is the charge present over here now? Yes, positive charge. So I know that this is positive charge. So this positive charge, I am going to bring it near and touch. So this is a positive charge. So this is glass. And this is good conductor, so this is metal. Now what happens? This is positive charge. Because this is positive charge, so ye positive charge will attract the free electrons which are present in this metal towards itself. Right? So accordingly, what will happen is, because this positive charge, when I bring it close to it, this positive charge is going to be transferred to this place, and accordingly the whole metal piece over here will become positively charged. Because I touched over here, इसलिए क्या हुआ, जैसे ही मैंने टच किया, जो भी चार्ज यहाँ पे प्रेजेंट था, वो चार्ज इमीडिएटली दूसरे में ट्रांसफर हुआ. See, this particular charge was just too much ready to move, but it could not move because it was on an insulator. As soon as it came in contact with the good conductor, it was just too eager to run to that particular place, and hence this charge over here is moving on this side. Now if you want to understand it in a but deeper manner, let's think it this way. What exactly happens in the atomic nature? This glass rod is positive charge. That means some of its electrons are lost and has gone with the silk. The glass rod was loved with silk. So the silk got certain electrons which were present in the glass rod are now transferred to the silk. So it is lacking the electrons. So this glass rod lacks electrons. So what happens is, when I touch this over here, the free electrons over here are getting attracted towards this thing and they are switched over here. So यहाँ पे से electrons, like for example, there was a deficit of 25 electrons, let's say 50 electrons was less over here. So what will happen? 25 electrons from here are going to go from here to here. So that this charge becomes 25 and this also becomes 25. Accordingly, this whole thing is now having 25 numbers of electrons less than the number of protons available with it. So protons are more and electrons are less. So hence this particular whole metallic body becomes positively charged. Okay. This is atomically it is happening this way. But you can in easy manner, you can just learn it this way. कंडक्शन में क्या होगा, मैंने अगर पॉजिटिव चार्ज लेके अगर एक कंडक्टर को टच किया तो ऑटोमेटिकली द होल कंडक्टर बिकम पॉजिटिवली चार्ज्ड. I brought a positive charge, so it is going to become positive charge. I bring a negative charge, it will become negative charge. So whatever charge I bring and touch to this metallic body, the metal body is going to attain the same charge which is present on the charge body. If the charge body is positive, metal becomes positive. If the charge body is negative, the metal becomes negative. So in this method, charging of conductor by conduction, in this method the conductor to be charged is touched or brought in contact with the charge body. That the conductor gets charged by the similar kind of charge on it, the conductor gets charged by a similar kind of charge as on the charging body. The charge on the charging body is shared by the conductor to be charged. So here we are, easy way out is that you are sharing. It has got 50 positive charge, so it is sharing 50 with this, 25 share हो रहा है. इसीलिए this will be 25 positive, this will also be 25 positive. So there is a sharing of the charge which is going to be present on the charge body by the conductor. Suppose we have a charge here to charge a metal rod A with a positive charge. Place it on an insulating stand. Take a positive charge glass rod B provided with the insulating handle and touch it with the metal rod A as shown in the figure 8.26a. Some positive charge of the glass rod B is shared with the metal rod A. Remove the glass rod B, the rod A gets positively charged, that is figure 8.26b. So now even if I remove this glass piece over here, you will find that this charge of positive charge over here will still be retained on this particular metal rod. So this is how I am charging a conductor using conduction. Okay. The explanation to this is, the glass rod B is positively charged, so it has a deficiency of electrons. I just explained you that thing. So it is positively charged, so it has a deficiency of electrons. Why? Because that electrons have run to the silk cloth. When it is touched with the metal rod A, the free electrons of the rod A moves to the glass rod B. Due to the loss of electrons in the rod A, it becomes positively charged. So that's what we say, that when you bring in contact with the metal rod, the electrons which are over here are going to rush towards the glass rod, and accordingly there will be positive charge formed on the metal. It may be noted here that an insulator cannot be charged by conduction because it does not contain free electrons. So it does not allow free electrons from the charged body to flow through itself. So this particular conduction can be done only on conductors. You cannot use an insulator and have it charged with the help of conduction. Okay, because there is no free electrons present in the insulator. So it will not allow the flow of electrons, and hence there would not be any conduction taking place. The next thing is called as by induction. So the B part is by induction. In induction, what you do is you have this particular charged you have a particular conductor. So this is the metal rod. You are going to place it in an insulating stand. So this is the insulating stand. Okay. Now let's consider that you have got a glass rod A, positively charged glass rod, and you are bringing it near to this one. So here what happens, you are not touching it, but you are just bringing it near. So this is glass, and we know that this will be positively charged. So you are just bringing it near to the metal body. So what is going to happen? You can imagine this one. Rubbed with silk, positive charge. This is the rod, metal rod. Got many free electrons on it. Okay, there are many free electrons in it. Why? Because it's a metal rod, so it's a good conductor. When the positive charge comes over here, what will happen? The electrons from all these places are going to be attracted towards the end of the conductor. See, यहाँ पे क्या हुआ? यहाँ पे ऐसे एक मैग्नेट जैसा आ गया, पॉजिटिव चार्ज आया, इसलिए क्या सब इलेक्ट्रॉन्स, सब नेगेटिव चार्ज आर रेडी टू कम ओवर हियर टू गेट अट्रैक्टेड टू दिस थिंग. Hence, all the negative charge from here is going to flow and they are going to come into this area. Okay, all the negative charge comes here. Because negative charges come here, so what is remaining here? Only positive charge. So you will find that as the glass rod is brought near, it is not touched, because if it is touched, then the sharing of electrons will take place. Sharing of the charge will take place. Here it is just brought near, and when it is brought near, the electrons will be attracted towards this end of near the glass rod, and hence they will be negative charge, and here it will be the positive charge. Got it? So, this is charging by induction. In this method, the conductor to be charged is not touched with the charged body, but it is kept near the charged body. The end of the conductor near to the charged body acquires a charge opposite to the charge of the charged body. यानी यहाँ पे positive है तो इधर negative बनेगा, यहाँ पे negative है तो इधर positive बनेगा. Till the time this particular thing is placed over here, there will be the negative or positive sign formed over here. But the moment I remove this, there is no flow of electrons, so सब ये चला जाएगा. So that's why the induction से जो भी charging हुआ है, that is only temporarily till the time the charge body is in contact or is near to the conductor. So the end of the conductor near to the charge body acquires a charge opposite to the charge of the charge body, while the other end far from the charge body acquires a similar charge as that of the charge body. So near end will be negative, further end will be positive. Suppose you want the charge of a metal rod A to be negative. Place a rod A on the insulating stand, take a positive charge glass rod B provided with the insulating handle or cap, and bring it near to A as shown in the figure. The end A, the end P over here, this one over here, will of the metal acquires negative charge, while the further end Q will acquire the positive charge. On removing the glass rod B, the metal rod A becomes uncharged as shown in the figure. This is very important. This induction is a temporary thing. If I remove this cause of induction, automatically the charge का जो separation है वो भी चला जाएगा. It is not going to be retained. ऐसा नहीं कि मैंने इधर रख दिया तो ये नेगेटिव आ गया, अभी ये पॉजिटिव हो गया, अभी मैंने इसको निकाल दिया तो भी ये नेगेटिव बचा और ये पॉजिटिव हुआ. ऐसा नहीं होगा. The moment I remove that thing, it will automatically turn back to normal, because then the proton electron will come back to its original position and then distributed evenly within this particular metal, such that there would not be any kind of charge present on it. So explanation wise, the positively charged glass rod B attracts the free electrons of the metal rod A. Therefore, the free electrons of the rod A move from the end Q towards the end B. So, because the positively charged rod has come over there, the free electrons which are present here are attracted towards this place over here. Okay? But they are not touching, so they cannot jump over. They are just retaining in this area. Thus, the end P becomes negative charge as it gains the electrons, and the end Q becomes positive charge as it loses the electrons. On removing the glass rod B, the electrons of the metal rod A move from end P to end Q to neutralize the positive charge. But if I want to charge this thing, then what I do? Okay, if I want to keep it charged, okay, I don't want कि मैं जब ये glass rod निकाल दूँ तो it should become this one. So what do I do in this case? So here, if I bring this rod over here which is positively charged, so there will be negative charge formed over here and positive charge formed over here. Now if I touch this end, if I touch this end, so let's see what we have. Now touch the end Q of the rod A by hand and then remove your hand as well as the glass rod simultaneously. So if I touch this over here and I remove this also over here, so what is happening? I removed this, so induction is no longer there. When I touched over here, the electrons are flowing through me. So यहाँ पे जितना भी deficiency था, अभी यहाँ पे क्या हो गया? There is a positive charge. So the more electrons from the earth is going to come into the metal. See, earth has got a huge number of electrons. Okay, earth has got a huge number of electrons. So it's always going to be a flow of electrons from the something to the earth or from the earth to something. So that movement is always possible when you are the medium for the transfer of the electrons. So when you touch this place over here like this, so the electrons from the earth are going to come inside the metal. So as soon as this is removed, okay, as soon as you remove this thing, the whole area has got more number of electrons because of the positive charge which was formed over here. So that's why you see, now touch the end Q of the rod A by hand and then remove your hand as well as the glass rod B simultaneously as shown in the figure A and B. The rod A becomes negatively charged. Explanation: on touching or earthing the Q end of the rod, the free electrons move from the earth to neutralize the positive charge at the end Q. Okay, so because this is positive charge, so positive charge होने के कारण the electrons are going to move from the earth to this point to neutralize this thing. पर मैंने यहाँ क्या इसको भी निकाल दिया. अगर मैंने इसको निकाल दिया तो ऑटोमेटिकली क्या हुआ? Some electrons already come to this metal which are extra. So because it is extra, so what will be the charge on this thing? So very soon, as if you remove all this thing, the charge which will be present on this will become completely negative. So this is how I can charge a body by induction. The same thing if I take an ebonite rod and do the same process, it can become positive charge. Like for example, यहाँ पे कोई charge नहीं है अभी, और अभी हम लोग क्या करेंगे? We bring an ebonite rod over here. So ebonite rod is negative over here. So what happens? Negative इधर आया तो automatically there will be repulsion and the electrons will be over here and the protons will be over here. So this will be positive charge. Now what I'll do? I'll touch over here and remove this. When I touch over here and remove this, electrons from here are going to flow down and go into the earth. So electrons कम हो गए, but मैंने यहाँ पे remove कर दिया है. So this charge will get distributed and all this will become positive. Okay. So on removal of glass B and hand simultaneously, the negative charge, that is excess from electrons at the point N B, gets distributed throughout the rod A, making it negatively charged. Note, to charge the rod A positively, an ebonite rod B rubbed on fur is to be used. So hence we have the difference between charging by conduction and induction. By conduction, the charged body is touched with the uncharged body. In induction, the charged body is not actually touched with the uncharged body, but it is only kept close to it. By conduction, the charge is shared, so the amount of charge in the charged body is reduced. Whereas in induction, the charge is not shared, so the amount of charge on charged body does not decrease. By conduction, the charge on the uncharged body is of the same type as that of the charged body. यहाँ पे ये positive था, तो ये भी positive आया. Okay? वैसे यहाँ पे क्या है? मैंने negative लाया तो इधर positive आया. So the charge on the uncharged body is the opposite type, so that type or to that of the charged body. Finally, on removing the charged body, the uncharged body still remains charged. So over here, even after removing it, it was still remaining charged. But here, if I remove it, so the charge on uncharged body remains only as long as the charged body is close. As soon as the charged body is removed, no charge is left on the uncharged body. To retain the charge, the far end of the body has to be earth. So this is what we understand, or this is about the different methods of charging a conductor. Okay, now this charging of conductor will be used for many reasons. So there is the two kinds of electroscopes. So to find out the different kinds of charge and the strength of the charge, we use devices which are called as electroscope, and there are two kinds of electroscope which we will be studying in the next video.